Hey y'all. Okay, this is for, what's the date? This is for April the 6th. We are going to have back-to-back lessons. This is going to be a two-part lesson, so I'm going to do the first part of this on Monday, and then I'll turn around and do the next part of it on Tuesday. So I know that's not typically what we do, but instead of me just going through this whole lesson and then assigning you a ton of work, I'm going to kind of break it up that way. Okay, so here we go. Let's get started. This is about logarithmic equations, you guys. So we're going to be actually solving these equations that have the logs in. There's two types where you have a log equals log, and then the other type is when you have log equals number. This is what we'll do on Tuesday. Okay, so let's jump in and get started on this. If you have an equation, which means there's an equal sign, so we have an equal sign here, and you have a log on both sides. The first thing that you're going to do is condense each logarithm. So you look at each side of the equation and say, is there anything that I can do to simplify that? No. Is there anything I can do to simplify this side? No. So if that's the case, you're ready to go to step 2. However, if you look at number 4, okay, if you look on this side of the equation, you'll see that there are two logarithms separated with a plus sign. Well, we can combine those using the multiplication property of logarithms, which just means that since there's a plus sign here, I'm going to multiply 4 times y plus 5. So I'm going to simplify this into a single logarithm. Then, once you have a single log on the left side and a single log on the right side, then you're ready to go to step 2. Step 2 says that if log b m equals log b n, then m equals n. So basically, if you have a log with the same base and a log with the same base, you can just cancel out the logs, set them equal to each other, and solve. Now, here's the trick about this. When you're doing this and you solve, this is basic algebra, algebra 1 even. What the issue is, you have to solve and check for extraneous solutions. What that means is that you worked your problem out, you got a solution, it says x equals this, but does it satisfy the logarithm? So that's what you have to do, plug them back in and perform a check. So here we go. For this one, we have log 5 on both sides. That's the same. So I'm going to eliminate the log 5s. Those cancel, and then I set 5x plus 9 equal to 6x. Like I said, basic algebra, I'm going to subtract 5x. That's going to tell me that x equals 9, because 6x minus 5x is x. This is just left with 9, so x equals 9. That is our solution. We need to perform a check. So that means this log 5 should be the same as this log 5. If I plug those in, this and this should be the same. That's the ugliest 9 ever. Sorry. Okay, so 5 times 9 is 45. 45 plus 9 is, what is that? 45 plus 9 is 54, I think. And then 6 times 9 is also 54. So you have the same thing. Log 5, 54, log 5, 54. That is a true statement, so this works. It's not an extraneous solution. It is the solution. Okay, let's look at this one. Same thing. Cancel, cancel. Set them equal to each other. I'm going to subtract 2 in. Negative 6 in. I'm going to subtract 1 equals 42. I'm going to divide by negative 6, so n equals negative 7. Okay? I'm going to plug them in, do my checks. So I have 1 minus 4 times negative 7. That's supposed to equal 2 times negative 7 plus 43. Now, you don't really have to write these out. You could just check them in your calculator. 1 minus 4 times negative 7 equals 29. 2 times negative 7 plus 43 equals 29. So again, we're good. Okay, so these worked. Let's go to the next one. Log 9, cancel, cancel. 6 and equals 3w, or not equals, but minus 3w equals negative 2y. So I'm going to add 3w. I said y, but it's w. So that's going to be 6 equals w. Okay, when you plug that back in, 6 minus 3 times 6 equals negative 2 times 6. Well, I know that's negative 12. 6 minus 3 times 6, that equals negative 12. So that's the same. But here's the issue. You are not allowed to have a log to a negative number. Oh, and y'all can't even see that. Sorry. So I did my checks down here. You can see that. That would be like saying log 9 negative 12. So that if we rewrote it as an exponential equation, then that would be 9 to the x power gives me a negative number. Okay, so not allowed. Okay, so I'm going to write that over to the side. Logs can not be negative. All right, no negatives. So that's not allowed. If you have a negative here, it's not a solution. It would be an extraneous solution is what that would be. Okay? All right, so now let's look at number 4. We talked about that briefly earlier. If you look on the left-hand side, there are 2 logarithms there separated by a plus sign. So what I'm going to do with that, you guys, is I'm going to multiply. And I'm going to multiply 4 times a binomial. Since I'm multiplying 4 times a binomial, that means I need to distribute that. So that would be log 4y plus 20 equals log 72. Now, I guess it would be fine if you didn't distribute that. You could do it that way and still get your solution, but it's really just up to you. So you could have just taken this and set it equal to 72, log 72, and then your logs are going to cancel out. Then you could have divided by 4 first and then subtracted 5. You're still going to get the same answer. So it's really up to you on the way that you want to do that. I just went ahead and did the distributive property. Now, your logs are here. Those cancel out. So you've got 4y plus 20 equals 72. Okay? I'm going to subtract out 20. 4y equals 72 minus 20, I think is 52, but I want to be sure. Yep. Divided by 4 is 13. Okay, again, we need to plug in and do a check. This side is supposed to equal log 72. There's nothing I need to plug in here, so I need to plug in 13 for 5. So, 13 with 5. So 13 plus 5 gives me 18. Okay, then I'm going to take that 18 and I'm going to multiply by 4. That gives me 72. So that one does check, which means this is a solution. Okay, now I realize that most of you guys are not watching these videos. Okay, like they're on YouTube. So what I'm going to do is I'm just going to flip over and show you guys the key. Okay, and so you can pause your video and look at that key to see how you are working those out. And if you've got questions, you can ask. I'm going to kind of just prep you on the next couple problems and then switch over to that key. So if you look at number 5, the first thing that you would do with number 5 is make that your exponent there. So that would be log 7, 4 to the 3rd power. 4 to the 3rd power is 64. So log 7, 64 equals log 7, 4a minus 8. So you'd cancel out your log 7, set those equal, plug it in and do your check. This is separated by a minus sign. If it's separated by a minus sign, you know that means you are going to do division. Once you divide, then you'd cancel out your logs, set them equal to each other. This has got your 1/2. Okay, so you would take that 1/2 and make it an exponent over here. So you have 25th to the 1/2 power, which is going to be 5. Sorry, you can't see that. 25th to the 0.5 is going to be 5. It's also like taking the square root of 25. So then that's going to be log 6/5 equals log 6/23 minus 4w. All you would do is cancel out your log 6, set them equal to each other, and solve. Again, this 2 only belongs to that 6, so that's 6 to the 2nd power, which is 36. And then this is 4. You're subtracting there, which means you are going to divide. 36 divided by 4, that gives you 9, right? So this is going to be log 3/9 equals log 3 2p minus 5. So what you do is cancel your log 3's, set those together equal to each other, and solve. Okay? For these two on the next page, 9 and 10, you are going to, I'm going to work these out because these have a 2nd power right here. So I'm going to just cancel out my log 4's. Cancel, cancel. That gives me m to the 2nd equals 18 minus 7m. Now, that's quadratic. That makes that quadratic, so I need everything to be on the same side so that it is equal to 0. M squared plus 7m minus 18 equals 0. You are writing that in standard form. This is like x squared plus x minus c. So ax squared plus bx plus c. Let me write that over here. That's standard form for quadratics, okay? All right, so then now that you've got that written in standard form, you have to decide, do you want to do the quadratic formula or do you want to factor? I'm going to try to factor. The factors of 18, negative 18, that give you 7. It's not 1 and 18, 2 and 9, that's it. So we want 2 to be negative, so then I'm going to have m minus 2 and m plus 9 equals 0. So I'm going to have m equals positive 2 and m equals negative 9, setting each one of those equal to 0. So these are my two solutions. Okay, guys. Most of the time, these are going to check and be fine, minus the one that gives you like a negative log. But usually these will check and be fine. Anytime you get two solutions, almost always one of them is extraneous. So you have to figure out which one it is. So for this case, if we look at this and we plug in 2, you have to do the 2 for both sides. So you've got 2 squared equals 18 minus 7 times 2. Okay? 2 squared is 4. 7 times 2 would be 14. 18 minus 14 is 4. So that checks. That one's good. It is a solution. Now I'm going to plug in negative 9. Okay? Negative 9 squared. Can y'all see that? Yeah. Negative 9 squared is supposed to equal 18 minus 7 times negative 9. Okay? Negative 9 squared. Remember, you are squaring a negative. A negative times a negative gives you a positive. So that is going to be positive 81. Okay? Then we have negative 7 times negative 9, which gives me positive 63. Two negatives give me a positive. So 18 plus 63 is 81. So 81 equals 81. It works. So that goes against everything that I just said. Both of these do work. But that's why you have to do a check. Because if you don't check them, you may just assume that both of these are solutions. And one of them may be a solution, but one of them may be an extraneous solution. Okay, let's look at this one. If we look at number 10, you've got this 2 here and you've got k to the second and a plus sign. So we're going to put 2k squared. That's going to be this log. Over here, this one's fine. Okay, the logs are going to cancel because we've got a log on both sides. So I've got 2k squared. And remember, this is just the k squared. The 2 is not squared. Equals k squared plus 16. Alright, so it looks like it's going to be quadratic, but I'm actually going to subtract this k from this one. That's just going to be k squared, I believe, because it would be 2 minus 1. That's correct. You're just subtracting their coefficients, okay? So the coefficient for this one is 2. The coefficient for that one is negative 1. So 2 minus 1 is 1. So that gives us k squared. And that equals over here 16. Now, I'm going to take the square root of 16 to get k by itself. If you remember that I told you this, from now on in Algebra 2, anytime you take the square root, it is going to be a plus or minus. Because 4 squared is 16, but so is negative 4. So our two answers for this are 4 and negative 4. So we need to do a check to see if they work. Okay, so I'm going to start with positive 4. 4 squared is 16. This is a plus 2. So we've got log 16 plus log 2. That's going to be log 2 times 16 is 32, right? Yes. I wish you guys were here to tell me. Okay, so then we come over here. We're doing the same thing. We're plugging in 4. 4 squared plus 16. So 4 squared is 16. 16 plus 16 is 32. So log 32. That one checks. Positive 4 works. So positive 4 is a check. It is a solution. Now let's check negative 4. If I plug in negative 4 here, negative 4 squared is going to be positive 16. 16 times 2 is 32. That one's the same. If I plug in negative 4 here, negative 4 squared is 16, positive 16. 16 plus 16 is 32. So again, negative 4 worked as well. So it is a solution. So far what we've seen are all good solutions. Okay, like I said, that's where we're going to stop for today and just do the first part of this lesson. Okay, I don't know what the last thing I said was because I thought I was recording and I didn't. So we checked this one. And I think I'm telling you that we are going to switch over and I'm going to show you the key. So pause it if you need to see the work for 5 through 8. Let me know if you have any questions. And don't forget that your homework is due tomorrow. You cannot wait around for this one. I'm going to have another live video for you tomorrow, okay? So be prepared for that. But no work Friday and no work Monday because of Easter. So okay, I miss you. I love you. Lily Jo wanted to put some artwork up here for you guys. So we are thinking about you guys a lot in this house. I'm just going to sit here awkwardly and let you guys copy this. I'm showing them the key, but like my face is still on here. Okay, we'll do the other ones tomorrow. Ciao.